IGDTUW. She was associated with Delhi Technological University. She has a teaching and research experience of more than 20 years. She received her BE degree in Electronics and Communication and M.Tech degree in Digital Communication. She pursued her research interest and completed her Ph.D. from IIT Roorkee, India. Her area of interest include medical image processing, deep learning, artificial intelligence applications, multimedia security, computer vision, soft computing techniques. She has published 4 book chapters and over 65 research papers in reputed international journals and international conferences. Now, I'm requesting to ma'am, please share your expertise with us.
Thank you, Akansha. Thanks
Thank
a lot. I hope I am audible enough and there is no
Yes,
problem
ma'am.
in the network at my end.
We are audible.
Thank you, ma'am. I'll just share my slides. I hope my presentation is clear. It's visible.
Yes, ma'am.
Yeah.
You can make it in the slideshow.
Yeah, I am doing that. I just wanted to switch off my video first. Yeah, very good afternoon to one and all present over here. So the title of my presentation is AI for making sensor data sensible. I think maybe 20 to 30% of the time, I'll be just sticking to this one slide of my presentation. The reason why, I think it's the third day of your presentation, and all of you must be aware till now, I don't know how many of the participants are faculty members or the research scholars and all, because Atal FDP is open for research scholars, M.Tech students, faculty members as well. So I assume that few of the members must be working in this area and some will be novice or maybe trying to learn about this area. So before coming to the work that I have done with my team in the area of IoT sensors, let me give a brief introduction of what sensors is, what IoT means is. I'm sure this is the third day of the presentation, when what I could see from the schedule is that many, just hold on, I have to just log out of my, yeah. Sorry. Yeah, sorry. This is the third day of the presentation, and there have been talks about various applications and the challenging issues of IoT and WSN. For now, I will start with sensors, IoT, and how AI makes its place in the area of IoT. So when we talk about maybe a sensor, this is something that all of us, we are using it in our day-to-day life. Not exactly using it, but we are using the devices which have sensors in them. We may say that it is an area which is, we don't want to work in this area. We don't know how sensor works and all, but we all are using it. For example, in your phone, many of phones nowadays, they come with that fingerprint scanner. It is a sensor that senses, okay, this is a finger, this is the correct finger or not a correct finger. It scans your finger and then matches it. Maybe, the microwave oven, the refrigerator, the health monitoring systems, all these systems, they are equipped with sensors. Nowadays, you go to any mall and the lights will be off in the changing room. But the moment you enter into the changing room, the lights immediately switch on. Similarly, in malls or maybe in some showrooms, you have sensors installed on the door. So when a visitor who is trying to enter into that mall, that person is within maybe half a meter or 20 centimeters from the door. Again, it senses and opens the door. So all of us, we are surrounded by sensors, different kind of sensor, and we have been using it since long. It's not today, it's not yesterday. Since last few years, we have been extensively using it. Now, when we are using sensors, what basically a sensor is, once we have seen the applications, let me technically define what a sensor is. It is basically a device that responds to a physical stimulus. This physical stimulus can be a heat, light, sound, pressure, or maybe magnetism or a particular motion. For example, you must have seen in the basements or in hotels, you have smoke sensors and the fire sensor, which senses whether there is smoke or there is fire, and accordingly either alarm will be buzzed, or the water will be sprinkled. So they are all the sensors. So a sensor is a device that responds to a physical stimulus. This stimulus can be anything, and it transmits a resulting impulse. And this resulting impulse can be in the form of maybe the way we have spoken, that either the water will be sprinkled or an alarm will be buzzed, or maybe some control action to be taken. So, for example, in air conditioners nowadays, you have temperature sensors installed. And if you have put your AC at a temperature of 22, so the moment it reaches 22, it does not give you an alarm. But yes, the control mechanism comes into action and it stops the further cooling. So based upon the area where we will be installing the sensor, the output stimulus can be different. So that is basically a sensor. And what does these sensors do? They measure, they take the physical stimulus and they give some output. This some output, whether it is a control action or an alarm, it is something measurable quantity. Something measurable. Why measurable? Because as per Lord Kevin, he said that if you cannot measure it, you cannot improve it. So the moment we have measured something, then only we can try to improve upon our system. So we have to get the data. And when we say we have sensor installed everywhere, and there is a control mechanism involved, that means there is a lots and lots of data involved. Lots of data, it can be in the form of a numeric data or a fuzzy data or image data, any kind of data. It can be in the form of pulses, it can be in the form of signals, it can have any form. And these sensors, earlier when this terminology was coined, IoT, it was IoT, Internet of Things, which basically means that we have sensors employed, and there is a central place wherein the sensor data is being sent, and the control mechanism is done through a remote center kind of thing. So that is basically IoT. It all started with IoT, but now if you look at the literature, along with IoT, many more terms have just coined in. I'll just name 2-3 terms out of this. One is industrial IoT. So you call it industrial IoT because it has many applications in the industry, in the PSU sector, in the private sector. So in industry, it has been extensively used. And why it is extensively used? Because it, in a way, it improves the reliability of the system. It gives you, again, as per Lord Kevin, if you cannot measure it, you cannot improve it. So once it is installed in an industry, you get the data from a remote sensor. You can analyze that data and you can do predictive maintenance, or maybe you can reduce the downtime. You can improve upon the reliability. So rather than taking random decisions based on the data, you can analyze, and you, instead of random decision, you can convert them into a evidence-based decisions. So that is why this industrial IoT came into picture. Now, when we say industrial IoT and so many sensors, so when we talk of so many sensors, means so many data, huge amount of data. This huge amount of data, that means you need analytics. So that's how the IoT or the sensors, they got clubbed with big data analytics. So then you have another term coined in big data IoT. Then you have AI IoT. What does this AI IoT means? AI IoT means you have so many systems which are working on through IoT, and the data is generated. There are times when for a particular area, multiple sensors have been installed. For example, if I talk of a room wherein, we people are sitting and we want to sense the temperature or some noise level. So there will be 10 different sensors. Why 10 different sensors? Because either it can have n number of reasons. First, I want to have data at multiple, because if you take an area of maybe 14 by 14 room size, so one sensor may not be sufficient enough to check the noise level of the room. So you may have to deploy various sensors. So you may need to check the noise level at different positions. That is why you are taking. Now, when you're saying that so many sensors are there, the final output will be a fused output. It will take, maybe if let's suppose there are 10 sensors installed, it will take those 10 sensors data and it will fuse them, and it will give you maybe one or two values. So these values will come out of fusion. Why fusion? Because if there are 10 sensors, out of these 10 sensors, there is a probability that all the sensors may give a different output altogether. And there also exists a probability that these sensors may give the same value. 5 sensors, they are giving the same values, 3 sensors same value, and another 2 sensors are different value. So that means out of the 10 values that I must be getting, many of them, they are redundant to me, because they are same values basically. That does not make any difference to me. So that's how AI comes into picture, which tries to analyze your data, which tries to use AI techniques to make the data sensible enough, so that it can, maybe for this, in this particular case, we can say that it just removes the redundant data and it gives you the distinct values, so that, and again, a evidence-based decision can be taken. And not always this decision is taken manually. Again, we have AI algorithms in place that can take a decision on your behalf. So slowly and steadily, you will feel that everything is being automated. Earlier, we developed certain things with the help of sensors so that you can remotely control it. With the coming of industry IoT and AI IoT, what we are trying to do is, rather than controlling it yourself manually, we are automating that process also. The decision making will also be done by AI. So that's how this IoT is emerging as big data IoT or AI IoT or industrial IoT, so on and so forth. In the times to come, you will see that this IoT, it has it will collaborate with many of the fields, and new terms will be coined up. For example, even if for this IoT, I'll come to this topic a little later, but when we say that these sensors are sending the data and the analysis is being done, we say that this analysis is basically done in three, matlab you can do the analysis at 2 3 points. What are these 2 3 points basically? These 2 3 points is basically, firstly, either you can analyze the data near to the sensor data origin itself. Secondly, what you can do is you can do the calculations or the analysis at the cloud level. These are the basic two data processing levels, near to the sensor node and near to the and at the cloud. Both, excuse me, both the processing levels have their own pros and cons. For example, if we talk to the near sensor data origin, this is further divided into two parts. One, you must have, may not be knowing, but you must have heard the name or the term edge computing. So we have heard the name edge computing. What basically edge computing is? It is basically the subcategory of data processing level that you are doing your processing near to the sensor node. So when we talk about the first category, either we do it in the edge computing form or we do it in the form of fog computing. But when we say that it is at a cloud level, so the name automatically indicates that all the data is being sent to the cloud, and the processing is also being done over there. And based on that, yeah, anybody saying anything? I think Arokia Itura. Can we mute Arokia? Yeah, thank you.
Are you changing some slides or not?
No, I am not changing
Okay.
my slides, ma'am. That is what I said, that
Yeah,
most
yeah,
of
you
my
told.
presentation, I'll be on the first slide itself.
Yes, yes. So participants are asking it. So that's
No, no,
why.
no, no. If they
Okay.
want, I can change it to the next slide. This I have already covered. I'll come
Yes,
to
ma'am.
this IoT. I hope my changing slides is clear to you.
Ma'am, we are not able to see any change right now. So
Okay,
yes,
right
we
now,
now we can see. Yes, we can see.
I'll just stop present. Is it visible now?
Yes, ma'am, you are. It's IoT applications. We can see
Yes,
the
I
slide.
think when I'm doing it in a F5 mode, then I think it's not clear to you. Can
Okay.
you change the slide? Can you see the slide IoT applications or the main slide?
IoT applications, ma'am.
Okay, right. Now in that case, it is, visible to you. However, I have planned the presentation as in to stay on the first slide itself. But if the participants need a little change of the slides, I can do in between.
No
So
issues, ma'am.
let me complete the topic that I was just doing, and then I'll come to maybe these applications. So we were talking whether the processing is being done near to the sensor node or it is done at the cloud level. Both the things have their own pros and cons. First, when we are saying that we are doing near to the sensor node, it is basically it basically requires the sensor nodes to have the storage, also to have the processing capabilities, also the decision making also. And it requires the sensor nodes or to have that computational power also. It requires the sensor nodes to have that much of battery life also. So all these things will be required when we say that the processing is being done locally. But in this case, at the end of the day, after doing all the processing and all, the final decision taken or the final analysis done, it is sent to the web. It is being sent at the cloud level also, it is being sent. But at the cloud level, what you are doing is you are sending the entire raw data to the cloud, and the processing power, the storage, the computational power, everything is in the cloud itself. So in this case, what happens is the sensor is free. Whatever data is coming in, you just send it to the cloud. But the problem is the enormous amount of data which will be transmitting. For example, if you are doing the analysis locally, then maybe, after 2 megabits of data, you might be sending only 1 kilobyte of data to the cloud, which pertains to the decision taken or the final fused value and all. But when it is the processing is done at the cloud itself, then that means 2 MB of data is being sent to the cloud. So you require that bandwidth also, and you need to, take care of the losses that might occur while sending the data to the cloud. There might be times, all of us, we are in online mode. We are sure that every one of us faces network glitches one or the other time. So similarly, when we are saying that we are not doing any processing at the node and we are doing all the processing at the cloud, so that means there might be some network glitches in between, and the data the packets may get dropped, and the final decision may be something else from what the decision should have been. So we need to take care of all the things before we decide what kind of processing do we require. Do we require edge computing kind of framework, or do we require the cloud kind of processing? So if you just Google it, you will find that so many white papers and so many things are being done to propose the framework, to come up with the white papers, and the architectures have been developed. There is an IEEE standard which indicates that what should be the architecture for IoT. You just Google and find out IEEE standards architecture. For IoT, it is defined as IEEE P2413. And based on this IEEE P2413, there are some open consortiums who are working for it, and those white papers are being submitted and finalized. Few of them have been done actually. So IEEE P2413 has already been put in place, and based on that, Cisco has developed their own architectural framework for IoT applications. Oracle has already developed their IoT architecture, and so on and so forth. So that's how these things are being developed. So let me just break the momentum and come to my slides. This is basically what IoT and what the Google says actually, Internet of Things. If you just see, and you will say that they are basically embedded systems. You have wireless sensor networks, they have their application in smartphones. I think this is the place from where I started, the fingerprint scanner and all, or maybe the doors in the malls or some showrooms, or maybe light control AC में आप use कर रहे हो. So this is basically IoT. It has privacy and security. Yes, with the emergence of IoT, what is happening is the artificial intelligence is coming into picture, the big data analytics is coming into picture. Well, I mean, people who want to pursue their research in IoT, there are so many areas that they can focus upon. Big data analytics, AI applications. There are privacy and security applications which are required for IoT systems. The battery power, maybe, and the communication protocols that will help for sensing the sensor data to the cloud without much of packet losses. Reliability can be addressed. So many things are there who are planning to do their research in IoT. So what does this IoT is basically? There, as I am sorry, I have not written the source over here, but these pictures, they have been taken from the Google. So the source, you can use it as Google. So there are 7 characteristics of IoT. For example, the first is basically one thing that I forgot to emphasize over here is whenever we are talking of IoT, you see the over here in the second paragraph, last line, the smartphones, smart speakers coming into picture. So whenever we are talking of IoT, we were trying to initially, ease up our work, but with the time, the use of IoT has been converted into smartphones, smart speakers, smart this, smart that. Why are they being called as smart? The reason is because AI is being integrated to that. Your Alexa is a very good example of an IoT and with artificial intelligence. Your smartphones, your smart watches, they are a very good example of AI with your, IoT. For example, if you have a smart watch, you wear that watch, it will count the number of steps. That means there is a sensor over there who will be sensing the number of steps taken. Based on that, it will give you your blood pressure also, the heartbeat also. It will give you n different parameters for which you must have set your watch, and based on your value, it will also indicate whether your blood pressure is normal or it is high or it is less. So it is again an integration of IoT with AI. So the places wherein you are integrating IoT with AI, you just add a word smart over there, because nowadays AI makes you smart, the use of AI. So that's how we use smartphones, smart speakers, smart watches. And the moment it becomes smart, that automatically means that somewhere down the line, data analytics is also coming into the picture. So the 7 characteristics is, firstly, you are trying to make it smart, you are trying to make it intelligent. The data information should be there. And based on that data information, decision making should also be there. The communication should be there. It should have sensors or devices. The connectivity should be there. See, for sensors, many sensors installed. The communication needs to, there are certain sensors, who can work independently, but in most of the cases, just hold on, I'll have to close that. Yeah, the communication needs to be there. Once you have that data, you need to send it to some central node or take decisions. So when you are sending that data and decision making is to be done, you need the connectivity to be there. So these are the 7 characteristics of IoT. And what are the applications? All of us know this is again a snapshot from Google, which gives you an idea of IoT application. It has applications in fitness. It has applications in smart retail, telecommunications, smart cities. Again, wherever AI is being integrated with IoT, you call it smart cities, smart factories, data-driven healthcare. Over here, I think, let me discuss. Yes. Over here, it's a data-driven healthcare, AI. And over here, since the AI data-driven healthcare has come, I'll just show a few slides wherein we have done a project with RML Hospital. It is again an IoT based, and we were using a couple of sensors to help them out in a crucial problem. The project is still not in the implementation stage, but yes, we did a few work for RML Hospital. I'll just discuss it after showing the next 2-3 slides. So this is the growth in IoT. This was again a graph taken from Google, but it's a little, maybe somewhere around 2018, some survey was done.
Excuse me, ma'am.
It
Which
indicates,
graph you're talking about, ma'am?
pardon?
Which graph you're talking
Slide
about?
My graph is not,
Yeah,
is
yeah,
it?
yeah. Now it is visible, ma'am. Can we have this in full screen also?
I think I need to
Ma'am, can you
stop.
put it
F5,
in the
F5,
slideshow
ma'am.
mode?
Yes, I have removed the slideshow mode, but the moment I'm keep doing it in the slideshow mode, I think the graph will go off. Is it visible now?
No,
Ma'am,
no.
you can change the percentage from 40% to I think 50, 60.
Right, I think I can do that.
Yes, yes, yes. Yes.
Yeah, better now, better now.
Yes, ma'am.
Yes,
Perfectly.
thank you. Thank you for bearing with this. Again, a network glitch kind of thing. So this is again a survey which was done somewhere around 2018. Again, this graph has been taken from Google itself, and it shows the growth in Internet of Things, and it shows you basically that how many devices will be connected to IoT in the times to come. If you just look over here, we have been working with IoT and sensors. I told you it's not today, it's not yesterday. We are working with sensors since a very long time. So it says 1992. I think in 1992, many of us might not have even born. We are working with sensors since then. So it says 1 million, and around 2000, it is 0.5 billion. So the term IoT was coined, specifically the term IoT, it was coined somewhere around 2009. And slowly and steadily after the coming of IoT, you will see that the number of devices are increasing. When IoT term was coined in, it was somewhere around 8.7 billion. Now it's already 2020, and as per this graph, there are 50.1 billion devices which are, which are connected together, and we are witnessing this change. With this IoT, the recent terms which are being coined in, you just go through the research papers of last 1 or 2 years, you will find AI IoT, big data IoT, industrial IoT. So people who want to work in this area, you can target AI IoT or big data IoT. I hope this next slide is also visible to you.
Yes, ma'am.
Thank you, ma'am. Yes, from that survey itself, the survey was done by IoT World Today. Why am I showing this is the AI IoT or machine learning IoT or big data IoT. That was a survey was conducted, and based on that, they took a figure of somewhere around 465 people participated in this survey, and a few questions were asked from them. Based on the response received, I am just showing two conclusions from that survey. One, are you using AI or machine learning in your IoT deployments? So 69% of them said yes, they are using AI and ML. And rest 31% said that they are not using AI or ML. They're simply controlling the systems manually or something like that. But yes, since 2018, I think this survey was 2018, 69% of the people, they were using AI and machine learning. Now, in the current scenario, this 69% might have reached maybe 89 or 90%. Second second conclusion that could be taken out from that survey is for what purpose are they using the AI or machine learning? Since sensors, we can do the control mechanism also, predictive maintenance also, performance monitoring also. So this graph on the right hand side shows that 57% of the people, they are doing it for performance monitoring. Once they know it, they can, again, Lord Kevin, if you can measure it, you can improve it. So 57% of the people, they are using AI ML for performance monitoring. 47% of the people, they are trying to integrate sensor data with the business data. Then 40% are using it for the forecasting trend. 32% are doing it for ensuring security. 32% for analyzing video or audio, and 31% for product designing and testing. So for this AI and ML, they are being used. Again, is this visible?
Yes, ma'am.
Yes. So the most popular technologies, if you just look over here, this big circle, it says that 67%, again part of that survey but with a different description. 67% uses IoT. Out of that 60%, these are two surveys done by two different agencies. 60% are using AI ML, and 37% uses edge computing. What was edge computing? Edge computing was the uh, uh, term wherein we were processing the data at the sensor node itself. Not exactly at the sensor node, but near to the sensor node. We are not sending it to the cloud, but we are doing computing near the sensor node. And when you say that the sensor node itself is doing the computing, then it is categorized as fog computing. So there are three kinds of computing paradigms that we use in IoT: edge computing, fog computing, and the cloud computing. Again, I forgot this term. The cloud computing again is an integration with IoT. So you have big data, you have AI, you have industrial IoT, and then you have cloud computing. So many integrations. You name a term, and I think it's working with IoT, because we basically are using a lot of IoT. Again, it shows the impact and various other things. Right. Drivers for IoT growth. What are the terms? What are the benefits due to which IoT is being used? First and foremost, before you go into this particular diagram, since it is convenient actually. When you say every time, many of us, we might be having the fingerprint scanner with us to open our iPhones or other mobile phones, but only few people will be there who will enter the passcode. It is convenient. It is very convenient that in changing rooms the lights are off, but the moment you enter, the lights automatically switch on. So it is a win-win situation. It is saving on the energy also, and at the same time it is a convenient to the user also, that every time he or she need not go to the changing room, switch on the lights. It's done automatically. So one of the reason why IoT is penetrating into our lives is convenience. It is a win-win situation. It improves the performance. You can take evidence-based decisions. The maintenance can be done easily. Downtime can be reduced. So many things. Similarly, now these are the six terms due to which IoT enabled by AI, they are penetrating into our lives, which is basically decreasing cost of CPU, memory, and storage. We have convergence of IT and operational technology. Big data, cloud, and fog computing के साथ you are able to integrate. Decreasing cost of megabit per second. Yes, this is an important aspect. There was a time, I don't know, many of you might have seen, when the mobile phones were introduced, then even an incoming call was chargeable. We have seen a scenario wherein I think incoming call was for 8 rupees or 9 rupees per minute, I guess, if I'm not wrong, and the outgoing was 17 rupees per minute within a particular region, maybe Delhi, maybe Bombay. It's not STD kind of thing, but yes, 17 rupees per minute is huge. Why? Because that time the bandwidths were costly. The cost of transmitting the data to the web was costly. Nowadays, what is happening is with the advancement in technology, the prices have the bandwidth. I must not say that it is cheap, but yes, the cost to the user has drastically come down and the transmission rate has drastically improved upon. So the cost of bit per second, if we look at from the user perspective, it has reduced a lot, and the reliability of sending the data has also improved a lot. So due to this, the IoT based things, they are being used by us more and more. And maybe we can say because there are so many applications which are based on this IoT and cloud based things, so that is why the cost comes down, because it's always happens that when it is masses, the cost automatically comes down. I'll just take a break for a sip of water. Sorry. Again, that is why IoT is coming down, sensor data everywhere, because we have sensors everywhere, so the data related to sensor is also everywhere, and we need to make sense out of that data. That is why AI is being used. And what AI can do is basically AI can provide better risk management. AI can improve the decision making. AI can help in classification or maybe calculation or decision making. All these things can be done through AI. Now, when we say, I have two things, either I get down to the data or I'll just share. um, Maybe for another 10 minutes, I'll just discuss about these slides and then I will show you the work that my group has done with the RML hospital. I'll end with that. So when we say sensor data is everywhere, we have so many sensors installed, and for example, one thing I wanted to discuss is in the forecasting, sensors are being used in forecasting and maybe maintenance or decreasing the downtime. How they are doing is with the help of sensors, they can sense that how much is the energy consumption of a house. We have people coming up to take the water readings or electricity readings from our homes, but if you look at the research papers abroad, they are trying to install sensors, and those sensors will sense the. I think the work has already started. If there are certain faculty members or research scholars from the electrical area, they can just confirm if it is there. They have sensors installed at their places, and instead of a uniform pricing, they are doing dynamic pricing in the sense, this is in the terms of electricity. For example, there is a time when it's a peak hour electricity time. This peak hour may vary from place to place. For example, for a residential area, the peak hour may be from evening 7 till morning 9 o'clock. For industrial area, the peak hour can be from morning 9 till evening 6 o'clock. So in dynamic pricing, what they do is in the peak hour, the electricity will be costlier, and in the non-peak hours, it's just like our hotel industry. Peak season में आपको hotel rates 30 to 40% higher मिलेंगे, and in the dull season आपको hotel नॉर्मल रेट से भी सस्ते मिलेंगे. सिमिलरली इन द केस ऑफ इलेक्ट्रिसिटी, इफ इट इज अ पीक आवर तो आपको इलेक्ट्रिसिटी कॉस्टली पड़ेगी 30 to 40% हायर. इफ इट्स अ नॉन पीक आवर it will be cheaper to you. So that's how in abroad the dynamic pricing of electricity is being done. But when they do this dynamic pricing, they have to sense what is the peak hour for a particular area. For example, if a person stays in industrial area, if a person stays in residential area, or if a person stays in suburbs or something. So what is the peak hour for that particular, not exactly the area, but for that particular house. So for that, they have to install sensors, collect the data. Yeah, they have to install the sensor at the residence or the industry, collect the data over a period of time, maybe a month or 2 months, analyze that data, and based on that analysis, they will have to see whether what is the peak hour. So if you look at this particular application, it is a very good combination of all the things. You are sensing the data and transmitting the data to the cloud. So the cloud computing is being done. Then the big data analysis comes in. So it analyzes the data, summarizes the data. The summarized data is fed to the artificial neural network, which takes a decision or classifies the different hours or different zones of the day as the peak hour or the non-peak hour. So if you look at this particular application, all the things, you have IoT also, you have cloud computing also, you have big data analysis also, and you have ANN also. So it integrates all the four fields together to take a final outcome that helps in taking a decision regarding the dynamic pricing. So I am sure if anybody is from electrical background or somebody who works about electricity tariffs at international level, they'll be able to tell what is the progress in this area. So now this sensor data is everywhere. I'll come back to the slides. I just forgot to discuss about this particular application. When we say that the sensor data is everywhere, so the sensor data can be in the form of a structured data, or it can be in the form of an unstructured data, which will be fed to the data analytics computing machine or maybe the AI networks. In all the cases, it's not necessarily that you feed the data directly for data analysis and then to AI. There may be certain applications wherein data can be directly fed to the neural networks. So when we talk about this data, it is either in the structured form or it is in the unstructured form. How do we define as structured and unstructured form? Structured form means we are clear that it is a temperature sensor or it is a motion sensor, and what are the values it is giving, what are the ranges that it should give, and all that data is in a in a proper format. In a proper format means I assume that 50% of the people who are attending, who are a participant of this FDP, they're teachers. So collecting the data and analyzing the data has now become a part of our life, of our profession. So there were times when we used to, send a Word file or a Excel sheet कि बच्चों इसमें entry कर दो. Now with that, what comes out is कि किसी ने EMFT की जगह नेटवर्क एनालिसिस के मार्क्स डाल दिए, किसी ने थर्ड सेमेस्टर की जगह फोर्थ सेमेस्टर के मार्क्स डाल दिए, किसी ने परसेंटेज डालनी थी और उसने अपने ग्रेड डाल दिए, राइट. तो एट द एंड ऑफ द डे जो फाइल हम रिसीव करते हैं, that is basically useless to us. We cannot use it in any form. So now what it is, with experience we also learn now we don't send any Excel sheet or a Word document. What we send is a Google form. And in that Google form, we clearly define what should be entered, and what are the, we also define that whether it can take numerical values or the grades. So if the column is for grades, if that Google form entry is for grades, so it will take only alphabetical entries. It won't take, and alphabetical also A to F, not beyond that. अदरवाइज व्हाट विल हैपन इज कि हमने गूगल फॉर्म भेजा, वो भी एट द एंड ऑफ द डे जो एक्सेल फाइल बनेगी करप्टेड ही होगी. सो earlier data was not structured when we were sending Excel or Word document, but when we started working with Google Forms and analyzing that data, it was a structured form of data कि कहाँ जहाँ पर अगर alphabetical values आनी है, alphabetically आ रही है, percentage है तो it is always less than 100, 100 के ऊपर नहीं जा रहा है, and so on and so forth. Another is unstructured data. Unstructured data means there are certain things for which there are no set rules. For example, if I ask you how is the weather today, somebody will say sunny, somebody will say hot, somebody will say cool, somebody will say pleasant, somebody will say not that good. So there can be n number of attributes that can n number of values that can be given to the weather. So when this kind of data comes in and it is not in a particular format, we say that it is a sort of unstructured data. So what do we want? We want our data to be good, so that the data that we are getting from sensors, we don't want that data to be redundant. The way I discussed that there are 10 different sensors in a room, and each one of them, either they are giving different value or they are giving the same value. The same value means a redundant value to us, and different value means again we have to fuse them together and get one particular value. So when we say that it's a data, then there are different types of data. We have nominal data, ordinal data, discrete data, and continuous data. I hope it is the name in itself indicates that what kind of it. Discrete data means only numbers, continuous data means floating values, gender or nominal data means maybe the gender or the ethnicity or the hair color. And when we say it is ordinal data means first, second, third grade, ABC, economic status, and so on. So whenever we are saying that it is a data which is to be fed to a neural network or data analysis is to be done, we want a good data which is complete. That means there are no missing values. A quality should be there. It should not contain any mistakes. The way I said, if it is a percentage tab, it should not be more than 100%. The quantity should be there, because whenever you are feeding it to, nowadays we are working, rather than AI, we are working with deep neural networks which require a quantum of data. वहाँ पे 100 या 200 entries से काम नहीं चलता. You need thousands of entries. And if the data is less, then we need to augment that data. This in itself is a very big research area, which deals with augmentation of data. So we need the quantity also, depending upon whether we are using AI or we are using deep neural networks. The data should be accessible. So when we are saying that it is the edge computing or the fog computing or the cloud computing is being done, the data should be accessible at the end of the day, and the connectivity should be good, whether it is transmitted to the cloud before processing or after processing. And we should be able to validate the data. For example, if there is a data, for example, there is an application wherein we are trying to have a remote access to industry, or maybe a very good example is of cloud computing. I'll give cloud computing IoT is in agricultural applications. For example, the seeds are sown in a particular field and the sensors are installed, and some remote area wherein we cannot go, or maybe the scientist cannot go to, examine every day. So what they do is they install sensors at different places. These can be the soil moisture sensors, or the temperature sensors, or the humidity sensors. So based upon when the seeds were sown, what is the value obtained for the temperature sensor, or the moisture sensor, or the humidity sensor, when can we expect the crop to be, up for cut, or is this crop getting rotten or something like that. So that can be judged. So this all is done through cloud computing, and again in a remote place. So in these particular scenarios, what happens is, let's suppose you installed these sensors and these seeds in 10 different locations, just to find out it's a new hybrid crop which you want to, what is the ideal place. तो आपने देहरादून भी कर दी, मसूरी भी कर दी, दिल्ली भी कर दी, and 4-5 more places, so that you know कि भाई किस एरिया में, किस टेम्परेचर कंडीशंस में ये क्रॉप आपको अच्छा आउटपुट देती है. दिस इज ऑल्सो वन प्रॉब्लम स्टेटमेंट. सो उसमें क्या होगा कि यू फॉर दोज 10 different locations you will analyze the data initially separately, and then you will club them together, and you will see कि कौन सी एक जगह है which is an outlier. अब वो आउटलियर मीन्स वो ग्रुप से अलग है. वो ग्रुप से अलग है तो फिर वो क्या है, वो अच्छी है, मतलब क्रॉप वहां पर अच्छी हुई या क्रॉप वहां पर बुरी हुई. सो यू नीड that outlier can help you in some ways, either for taking a decision. So that's how you have these are the basic 6 qualities of a good data. So we have to predict, describe, design, collect, clean and fit data. Clean data means again data जो है वो आपका, जो हमने good data बोला, so it should be good. And the moment आप कहते हो कि it's a good data, तो उसमें क्या है कि भाई if you talk to industry persons or data analysis people, you will find that they will say कि भाई हमारे पास जो डेटा आता है वो इतना corrupted है. Even research says that 80% of the time the data scientists, they are busy in cleaning the data, because जब तक वो डेटा क्लीन अप नहीं होगा वो आपको डिसीजन अच्छा नहीं देगा. इट्स समथिंग लाइक जब तक फाउंडेशन स्ट्रांग नहीं होगा, योर बिल्डिंग कांट स्टैंड फॉर अ लॉन्गर टाइम. So that's how they have to clean their data. Once the data is cleaned up, decision is quicker and decision is reliable. But if the data in itself is not good, then they struggle a lot. And as per the research, as per the records available, companies spends 80% of their manpower and time and cost in just cleaning the data, and only 20% is consumed for decision making or developing the system. So this cleaning is a big part in data analysis and AI. So I think I'll switch to the another presentation. I have so many things to discuss, but I'll show you one application of IoT that we have developed for RML hospital, and then the house will be open for any kind of questions. Ma'am, is this slide visible to you?
Yes, ma'am.
Prognosis and monitoring of comatose patients. Oh, yes. This is basically one project that we did with RML Hospital, and this our B.Tech students they did it along with me. They have published one paper also on this, and this basically in this what happens is, if I talk about the problem statement is, there are times when the patients are there in coma condition, So when they are in coma conditions, there are various factors that need to be considered. Firstly, when they are in coma, people won't be around them. But it is crucial for the doctors to see कि patient क्या even for a minute second क्या वो कोमा से बाहर आया, क्या उसने अपनी आईज ब्लिंक करी. लेट सपोज कि डॉक्टर को ये भी नहीं मॉनिटर करना, बट स्टिल अ पर्सन हु इज इन कोमा, आप उसको फूड पाइप तो लगाओगे, आप उसको यूरिन पाइप तो लगाओगे, आप उसका बॉडी टेम्परेचर तो मेजर करोगे ना. एंड जनरली क्या होता है व्हेन द कोमा पेशेंट्स आर देयर, उनको डिफरेंट सेंसर, डिफरेंट फूड पाइप, ग्लूकोज पाइप एंड यूरिन पाइप, ये सब लगा दिया जाता है. एंड द नर्स हैज टू गो एट रेगुलर इंटरवल्स टू चेक कि भाई सारे पैरामीटर्स विद इन रेंज हैं या नहीं है. The pulse, the BP, the temperature, urine bag भरा तो नहीं, all those things. And considering the scenario, खैर जब हमने ये वाला project किया था, it was I think in the last semester we did it. Actually we started it and in between lockdown happened, so we could not continue it further. We stopped going to hospitals per se for these issues. Otherwise we were trying to collect data from the doctors, but still the students did a good job. So the patients have been equipped with so many sensors, and doctor या नर्स रेशियो एज पर द पेशेंट रेशियो पहले भी बहुत कम थी, और आज की सिचुएशन में पिछले 1-1.5 साल में तो बहुत ही ज्यादा कम हो चुकी है. Half of the time doctors, they are in the quarantine or positive because they are so much exposed to the virus. So in this statement, what we did was we call it a Glasgow coma scale. It is a standard scale which has been developed in the literature itself. So it has two things. One is the monitoring system, and another is the Glasgow coma scale, which is well developed and used in the research. In the monitoring system, different sensors are installed in the patients, and based on those sensor values, the coma scale is used to evaluate the condition of the patient. What are the parameters that we measured? In this, we developed a glove basically. That glove will be put in the hand of the patient. So that glove basically has 4 sensors installed: body temperature, pulse rate, urine level, and limb movement. Based on the values of these sensors, there will be a control panel. It can be installed in the central monitoring room, and there is an app also. We developed the front end also. The app can be developed, can be installed by maybe जिसके भी घर का patient है, they can also get that installed कि भाई ठीक है मेरा so and so is in coma at such and such hospital, तो उसके parameters, body parameters क्या है इस time, it can be seen through that app also. So these were the 4 parameters that we measured. And जो app फिर वो I'll show you the picture of the glove. This is the glove that was developed. The patient has to wear this, and there are 4 sensors equipped in this. If you look at over here, there in the glove you have sensors. This bottle we have kept as if an indicator of a urine bag. So I'll just come over here. The test was performed. It had 2 verbal responses or the motor responses. Verbal response means the patient is trying to say something, and there are times the patient is cannot say anything, but yes, थोड़ा सा finger movement है या eye blinking है, कुछ इस तरीके से. So this was the basic block diagram wherein we have a client. These are the sensors. The power supply is there. If the patient is trying to say something, if it is a verbal response, then we need a voice recognition module, and all these things will be sent to the host or to the app, and if required, if they don't want it to send to the host or any display system, then a buzzer will be buzzed. Or you alternatively, you can have a display also and a buzzer also. Anyway, it can be done. So once we have the vital signs of the patient, uh, I'll just show you the mechanism wherein this is the Dr. Neerja Banerjee, जिनसे हमने बात किया था, ICU में वो होती हैं, and वहाँ से we had the idea of this particular thing. So these are the values that we have obtained in our app, and ये left side में आप देखोगे वो वहाँ पर ये लेफ्ट राइट वाला ऐप पे जा रहा है, एंड जो राइट वाला है वो उनके डेटाबेस में स्टोर होता जा रहा है. आई वो जस्ट यस, these are the scoring systems as per GCS, glaucoma comatose patient, wherein we have correct name and place ओरिएंटेड. मतलब आप पेशेंट से पूछोगे, कुछ क्वेश्चंस पूछोगे, अगर वो आपको ठीक जवाब दे रहा है, देन ही और शी विल बी गिवन अ स्कोर ऑफ 5. इफ दिस इज एन डिसओरिएंटेड कम्युनिकेशन, कंफ्यूज्ड है पेशेंट, तो 4. पेशेंट कुछ बोल रहा है, वर्ड्स बोल रहा है, बट यू कांट मेक एनीथिंग आउट ऑफ इट. Or maybe if you are not there, the voice recognition system is there. I showed that in the block diagram. Then 3, and so on and so forth. Similarly, over here, if you see the motor response, तो आप इसमें आप देखोगे no movement, little movement, थोड़ा सा body stretching है, full extension है. They are trying to obey the commands also, कि हाथ हिलाओ, आंखें बंद करो या जीभ बाहर निकालो, and so on and so forth. You give them the response, and based on those responses, the AI can take a decision. The AI can maybe forecast कि कब तक patient पूरे तरीके से ठीक होगा. तो इस तरीके से we have tried to use IoT sensor based system, but we could implement it only till the the IoT and the app part. We could not extend it to the AI, or data analysis was also there, but not to AI for forecasting or prediction of anything or the decision making. It was simply through that app based. We intend to extend it further. So that's how we have used it. I think I'll just stop over here, and we are open for any kind of questions that we have from the participants.
Participants, please ask questions. Is there any question from the participant side?
I think none, ma'am.
Yes.
At times it is a very good sign also. At times it is a very bad sign also, because since this was probably a post-lunch session, people might...
Ma'am, it was really a very wonderful lecture. Actually, you have done so much practical work. So it's really nice to see such work.
And I tried not to keep it very complicated, because there are times, when you start discussing a lot of your research area and your results and everything, because we know everything and we take everything for granted for the participants. So
Yes.
everything goes for our, toss. I did not want that for the lecture. So I tried to, cover a lot, many things, but in a very simple and informative manner. How the participants have taken it, I am quite, unsure.
Participant commented that it is a very informative session.
Yes, ma'am, that I could see from Seema.
Yes.
Actually,
Yes,
it
many
has become
ideas.
such an emerging areas, and so many, with AI, big data analytics, whatever field one has interest, they can they can integrate.
Right. Right. Akanksha, you there?
Yes, ma'am.
Okay. Okay. So, ma'am, should we wind up now?
Yes, now we can wind up.
Okay.
So now I would like to thank Nidhi ma'am, who honored this FDP and enlightening all of us with her expertise. We learned various important aspects like history of IoT, IoT enabled by AI, edge computing, cloud computing, sensor data, different types of sensor data, how we analyze the data. So all these things are very important, and we really learned a lot from this lecture. Thank you so much, ma'am, for this informative lecture.
Thank you, Akansha.
Thank you, ma'am.
Thank you,
Thank you.
ma'am. Thank you, Gurjeet, ma'am. And
Thank
thank
you.
you all others for a patient listening.
Thank you, Professor Nidhi.
Thank you, ma'am.
Thank you.
So, ma'am, should we wait for time?
Let us start. Okay, we'll finish early, no problem.
Okay,
Okay,
yes.
all are there, then we can start.
So, Akanksha, you can start.
Yes, ma'am. So, now I'm going to introduce our next eminent speaker, Professor S. Indu ma'am. Indu ma'am is currently working as a Dean Student Welfare in Delhi Technological University, Delhi. She has more than 20 years of experience in teaching and research. She also worked as a head of department at the Electronics and Communication Department in DTU. Her academic qualifications include B.Tech, M.Tech, and Ph.D. She has completed 3 research projects, and her area of research are computer vision, image processing, and wireless sensor network positions. She has won an Outstanding Branch Counselor Award for 5 consecutive years. She has various research papers in international journals, national and international conferences. Now I'm requesting to you, ma'am. Ma'am, please share your experience with us.
Thank you, Akansha, for the nice introduction. And as the coordinator of this program, I would like to thank all participants for patient hearing and your continuous support. And I'm really thankful to all my colleagues, that is especially Professor Gurjeet Kaur, who has coordinated this event in a very nice way, an excellent way, and all team members who worked for this. So with these words, let me start my lecture. I hope my screen is visible.
Yes, ma'am.
Yes, ma'am.
So I will be talking about optimization of energy efficiency of wireless sensor network using evolutionary algorithms. So actually this work is actually the outcome of the research of my 2 PhD students, that is Dr. Ajay Kaushik and Dr. Saji Anthony. And co-authors of the papers include Professor Daya Gupta and Professor Rajeshri Pandey. My sincere thanks to them for allowing me to present this work here. I will be going ahead like this. I will be introducing wireless sensor network. Wireless sensor network, you are being heard in all lectures. Most of the time it is being repeated. And then specific characteristics of the sensor network, I'll explain it because I'll be looking into the efficiency of the sensor network. So in that way, I will be looking about the characteristics of sensor network. Then I'll talk about issues and challenges related to efficiency of a sensor network and how optimization algorithms can be used for improving energy efficiency. So this is basically for in the software part, how we can make it better. And you can even improve the efficiency by improving the hardware of the sensor node. That also will be discussed, and then I'll be concluding my lecture. This is how I'll be going ahead. So this, we all know that the wireless sensor network, the emergence of wireless sensor network has come from the dream of a well-known scientist, Mark Visser. Yesterday, Professor Karan Verma also said about this sentence, because this was the starting of wireless sensor network. 30 years before, approximately 30 to 31, now 31 years is over. See, this Mark Visser dreamt something, okay? His dream was like this: the most profound technologies are those that disappear. they weave themselves into the fabric of everyday life until they are indistinguishable from it. So this was his dream, and we are seeing it right now. See, the essence of it is creation of environments saturated with computing and communication capabilities, yet gracefully integrated with human users. This is what we are seeing right now. Like everybody has a phone and we are all connected. So basically we can say that computing environment has come, and it is with every human being right now. Now it will extend to things also. So when it is extending to the devices, maybe the pen we use, maybe the bottle in which water, the bottle of water we use, maybe the notepad which we write. So everything can be connected together. So that means the computing environment is generated, and but it is gracefully integrated with human users. We will not be able to see the device. The device will disappear, but computing environment will be there. So this is the basic this thought was the fundamental thing behind the emergence of wireless sensor network. So this actually, now we are seeing all these things, but it started with the evolution of wireless sensor network. The first concept, the concept of wireless sensor network emerged as a first step to make Mark Weiser's dream true. So wireless sensor network was the first thing which anybody envisaged for coming to this stage. The wireless sensor network means what? It is a highly distributed network of small, lightweight wireless nodes deployed in large numbers. So you will be having, we can deploy large numbers. Nidhi was also telling about this, because we will have redundant information. So redundant information is a must in case of sensor nodes. Reason behind is that, like, once you deploy a sensor, it is unattended then. Nobody will not be able to connect the sensor to a power source always, or we can charge like our laptop or mobile phone. We'll charge it every day, but in case of a sensor node, we won't be able to do that. So therefore, if one sensor node one sensor node dies, the other sensor node should take care of its action. So therefore, redundancy is a must in case of wireless sensor network. For example, if you want to have a surveillance of your forest area, or maybe some place where fire happens in between, some in such kind of information, or maybe your like this pollution monitoring or weather monitoring. So for all these things, we have to deploy redundant sensors. So in its characteristics, redundancy is there. Without redundancy, it will not work. Then these sensors will be sensing some phenomena, and they can coordinate with themselves, they can process it, and then the relevant information will only be transferred. So wireless sensor network consists of protocols and algorithms with self-organizing capabilities. Self-organizing capability is also must in case of wireless sensor network, because if every sensor, say for example, if we have 10 people standing in a place, and even though if they are telling the same thing, we will not be able to make out anything. So that means they should coordinate, they should self-organize, and only relevant information should be passed on to the base station, so that the effectiveness of, or the efficiency of the sensor network will come up only like that. So in a visual way, we can see that, see, for example, this can be some sensors used for your weather monitoring. This can be some sensors, like maybe camera as a sensor, it may be monitoring, or it may be surveil, maybe road transport monitoring system, or a crowd monitoring system, or anything. So different sensors will be, then we have a variety of sensors. There is no depth of sensors now, so many are there. So each sensor, each network will be having some output, and that can be connected to the internet, and from the internet human beings can access it. It can be used for, the data can be used for analyzing the information, maybe processing the information. It can be stored or it can be used for mining. Like if you want to find out anything, you can do that. So this is how the whole system will be working. So in case of now how basically a sensor node will be containing, what a sensor node contains. You might have heard this many times, but still I am repeating it. It will have a sensor for sensing the information, and it will have a processing element. Processing element is a must because it has to process the data, and the processed data only has to be communicated. So now the issue is that, like, if the sensor has some information, and if it is communicating to this node, what all the sensor will communicate? The sensor in the communication packet, sensor will be communicating about its ID, because every sensor will be given a local ID and its location also. And then you will have a data. So this node will be able to know that from which sensor it is coming. Accordingly, it can aggregate things. So for all these things, you need a processing element and you need small memory in every sensor node. So therefore, it will have a sensor, then it has a processing element, and then it should have a communication element, that is a transmitter and a receiver. Both should be there in every sensor node. So they can communicate and coordinate with each other. So they'll communicate and coordinate. But the basic structure is distributed computation or distributed communication. That is, this node can talk to only this node. But this distance may be higher that it cannot, because it may not be coming in this range. Basically, a sensor will be broadcasting information, and these type of sensors are omnidirectional sensors, where it broadcast and it has some range over which the information will be available. So this will be able to communicate to only this node. It will not be able to communicate to this node. So the computation is distributed and the communication is also distributed. It will send some data here, then this will send this data. It can reach here only in this way. I will not be able to communicate from here directly to here, because the range of the sensor is the limitation. So see, I have talked about this. You have already heard, like, there will be a sensing unit, there will be a processing or a storage unit, and there will be a transceiver. But along with that, you can have other hardware capability of the sensor nodes also. It has got a localization capability. What do you mean by localization? Localization means, suppose, see, this is a surveillance field where we are placing sensors. So if a sensor is placed at some location, somewhere here, maybe in the middle, then it should be able to identify its location with reference to the field. See, I told you, like, whenever a sensor communicates some data to another one, it will be communicating its location and its ID. So this location has to have some information related to the local, because if you have a GPS, it can have only latitude and longitude, but it will not be able to know in which area of in which point, maybe in the middle of the surveillance location or towards the end of the surveillance location, because if they have to communicate and coordinate, then they should be able to know where its location is. So basically, you can use the triangulation method for identifying the location of each sensors. So that will be also a part of your sensor node. We can give mobility to sensors. How will we give mobility for a sensor node? Simplest example is to consider you take a toy car, like remote control toy car, where you might have seen kids moving this car more forward, backward, sideways, and all. So if you can give that control, the remote which you do in the to the processing device, then the processor, this can make the sensor move also. So this is another capability which we can introduce in the sensor node. So these two are the things which we can introduce. And another one is basically, and this is lots of research is happening in this. Reason behind is that like energy, like for example, if we can have a solar powered node, but solar powered node is difficult because it will not work indoor. What we talk about the sensors basically maybe indoor or outdoor, and outdoor also it should get sunlight. And for the time being, we can even say that the solar cells are a bit bulky, so that it may not be that viable. But anyway, time will be coming when we can have small solar cells so that it can be used for powering the sensor nodes, solar energy, or it can even have different various energy surrounding it, like maybe radiations, any radiations or so, it can consider it, and then it can have. So here in this area is very open. You can have a lot of research happening in this area, how we can energy scavenging of sensor nodes. So these are the hardware part of wireless sensor node. So now let us again look into the characteristics of sensor node. That is, it is densely deployed at, as I have said earlier, we will have redundant sensors, and it is prone to failures because we know that a sensor node may not be having sufficient energy to communicate after some time. So it may die after some time. So it's prone to failures. Communicating among nodes by broadcast, that is, of course, it can communicate by broadcast. So it can communicate only to the nearest one. It cannot communicate to a larger distance. Limited computational resources. Of course, we cannot have a big computer or a processor in a sensor node. Sensor node, basically, if we increase the computational capability, again, the power requirement will be more. It becomes bulky. And if we increase the memory element, that also going to make the sensor node power craving, and we will not be able to use it at all. So these are the main constraints, that is computational resource is minimum and memory is minimum in case of sensor node. They will have local ID. Local ID we have to generate because localization is a must in case of sensor network. And we have to program it for self-organizing. Self-organizing means like it should know whether it is getting information or not. If it is not getting information, is it because of the failure of the surrounding nodes, or because of sensors are not there or not. And if it is moving, if the sensors are moving, then it should be able to identify the path through which it should move so that it can get correct information. So all these capability, we can program the sensor node, we can program the processing element, and we can have a self-organizing capability. Applications are many. I have written only 10, but it is many. Many applications are there. Look into any area, you can have an application for the sensor network. Surveillance is the most commonly used application of sensor nodes. Then now because of IoT, we are having smart city, smart health, smart home, smart mobility, smart building. Name anything with a smartness that is, if you have an AI capability in anything, it is going to be an application of sensor networks only. So you can have many applications are there. Now, what are the basic constraints? That is, it can communicate. First thing is that it can communicate only in a distributed fashion. And once deployed, it is unattended. So power failure will be there. And processing data in the local level. Processing data level is a challenge because we have to process it with minimum computational facility and minimum memory. So that is it. So these are basic constraints for the efficiency of a sensor network. So now, how we can achieve energy efficiency in a sensor network? see, redundancy is one thing. So redundancy we can overcome by using a clustered network. You should have a cluster head, and that cluster head only will be communicating to others. Cluster head will receive all information and it can process it, and then the processed information can be communicated. So this is the first thing, the first ever method used for increasing the efficiency was clustering the sensor networks. Then now next thing is that you have to balance the energy in cluster heads, because suppose one node is like every sensor is communicating to the cluster head, and if the cluster head remains same, then your cluster head die first. So if the cluster head dies, then we can say that it is your sensor network has become a failure, because no other sensors are communicating to the cluster heads. So you have to balance it. So this way, by balancing this, we can increase the lifetime of a sensor network. Then optimizing the communication path. Then optimizing position of sync node. Like we can optimize the communication path. That is, if you optimize, see, the main energy drainage is due to the communication. So when you transfer data, energy, that is the highest power consuming part in case of a sensor network. So if you can optimize path, means the energy can be minimized. Energy dissipated can be minimized. Optimizing position of sync node. So you can even you can have a movable sync node, and then sync node can come near or the base station can come near your sensors, so that it can be the energy can be we can conserve the energy of the network. Optimal combination of modulation schemes and error correcting codes. This is actually, if you use in security, if you are using some secured information, then there also you can optimize things to reduce the energy. Then by modifying the architecture of sensor nodes, you can even modify the hardware part of sensor nodes and you can optimize things. So let us now discuss about the energy efficiency part of the sensor network. So initially, the first ever energy efficiency work has been done by by defining a cluster head. So how will you define a cluster head? Cluster head can be like, if you keep on making only one as cluster head, definitely it will lose energy and then it can create a problem. So, but initially it was like that many sensors are there, all sensors are communicating, that all creates squares, and then you will not be able to get correct information. And by the time you get a good information, maybe the sensor network life ends. So for avoiding that, you can have cluster heads. So this can be decided like by maximum number of nodes nearby this sensor. Like these are all sensor nodes and this is a cluster head. So this all nodes are equal, and we'll define one as cluster head due to the property of it. Maybe the remaining energy in this sensor node is high and it is nearby a maximum number of nodes. So by making sure of that, you can make this as a cluster head. So if you make a clustered network, definitely your energy will be improving compared to a network without cluster head, because every information is message flooding will come and will not get a correct information. So now, so this was being done earlier. You might have heard about leech protocol, and leech protocol was used for clustering the sensor network. So now what we have done is, in our proposed method, we have used these data. We have reduced, like we have optimized the protocol by considering distance between sensor node and a cluster head, and distance between cluster head and a sink, and number of hops. So we used some artificial intelligence based algorithms like biogeography-based optimization method for efficient, for improving the efficiency of the sensor network. So this is an example like which we have done, biogeography-based optimization. So what do you mean by biogeography-based optimization? Basically, you will be having a vector, and this vector can be used for calculating the habitat suitability index or fitness value. Habitats having high HSI value emigrate species to habitat having low HSI value. Similarly, habitat having low HSI value immigrate species from the habitat having high HS value. So immigration and emigration are the properties of biogeographic based optimization. So what we want to say that we have to find out some variables, and because of those variables, the suitability of that node being a cluster head is being calculated. And if it is suitable, it will remain as a cluster head. If it is not suitable, some other node will become, this will become only a sensor node, normal sensor node, and the other sensor node, which is having higher suitability index, will become a cluster head. Means like in here we have prepared cluster head once, depending on its energy, the remaining energy, and maximum number of nodes nearby. And then we stopped. So later all these sensors will be communicating to this, therefore there can be a possibility of failure of this node as early as possible. So the whole effect of the sensor network will come to an end due to the non-availability of the cluster head. But here what we are doing is that we are optimizing it, and we'll be changing the cluster head dynamically depending on the parameters, like these parameters. So that we have implemented using, this can be done only using evolutionary algorithms only. So we have used BBO method. So in extended BBO, the habitat suitability index depends only on immigration and emigration. Instead, it is a function of varying characteristics of the habitat. So we have identified some variable, that is, you can say the suitability index variables. Some variables we have identified, and this habitat suitability index is a function of that. So we can calculate it. The habitat suitability index can be calculated using this variable, and then it can be utilized for changing the role of a sensor node as a cluster head or not. That can be done. So this we have explained it as extended BBO with the cluster relocation. Okay. This extends the lifetime of the cluster head by optimizing the location of it related to sink and a sensor node, along with minimizing the number of hops taken for transmitting the data to sink. This improves the lifetime by nonlinear mapping of cluster head identification. So basically, if I explain it, it is something like that. Like in here we have seen that this may be sensor node 1, 2, 3. And that may be connected to cluster head 1. Okay, so we have to make a vector. That is, this cluster head 2 is connected to cluster sensor node 1. Again, it is connected to sensor node 3. It can be connected to sensor node 4. And this cluster head 1 is connected to sensor node 2, and it can be connected to sensor node n. So we will make a vector like this. And this vector can be, of course, it is very easy to modify this connection. This can be randomly changed. And each time we'll calculate the value of alpha, the fitness function. Okay. What is alpha? Alpha is nothing but it expresses the ability of the cluster head to communicate. So see if the distance between the cluster head and the node is lesser, so it can have a better communication, or the energy dissipated will be less. Or it can be if the distance of jth cluster head to the sink, if it is lower, again your communication or the efficiency will be higher. And if number of hops is less, then so using this equation you can calculate the value of alpha. So for each vector we will be continuously changing the vectors, and for each vector we will define the cluster heads depending on the value of alpha. We'll calculate alpha. So the vector with which maximum alpha we received will be made as our final connection, and then we will have that where this in this, like, we'll be changing it, and at one position we'll get maximum alpha. The moment we will get maximum alpha, those combination of connection of sensor node to the cluster head will be defined, and those nodes will be defined as cluster heads. So basically it depends on distance of sensor node to cluster head, and distance from cluster head to sink, and the number of hops taken to reach sink using and this is an algorithm which we have used for finding out this, and that will be the shortest route. So this way we have calculated the value of alpha, and when the moment and the vector related to maximum value of this fitness function is considered, and we have got a better result. So see, now in this case you have randomly deployed sensor nodes, and then you have a sink node here, and using extended BBO we have formed the cluster heads. And this process will be repeating. It is dynamic, so that our lifetime of the sensor network will increase. So we have tested for packets received by the base station, number of cluster heads changing. So these are some results which we have picked up from various papers, and we have seen that our algorithm is better than the other existing course. We use the same combination of nodes for calculating this value. Now the question is, now suppose, see, we have formed various cluster heads now. Now the question is, if only one cluster head is connected to the base station, what will happen? This cluster head is receiving information from everywhere, and it is the one to communicate with the base station. So this is going to be very, very critical. Suppose this node dies, then the whole sensor network will be useless. Whole will be useless. So it is now we have to balance the load in a sensor node which is connecting to the base station. Okay. Earlier, what we have done, we have just made clusters, so many clusters, and the cluster will be communicating to the sink node. And now the load, for example, maybe these three clusters will be communicating the sink node, and they are getting information from everywhere. So that is to be avoided. Even this node is to be changed intermittently, so that you can have a load balancing can be done. So for that, actually what we have used is, we have done, we can say that it is called connected dominating set. Okay. So this is a backbone structure of a sensor network. Suppose these are the clusters. Maybe this cluster can be identified using BB only. And after identifying the clusters, then we have, like, we formed a backbone, like connected dominator sensing nodes. See, in this case, we define a sensor node, which is a cluster head, as a dominator, and a sensor node, simple sensor node is defined as a dominating. So that is why it is dominating and dominator. So you have these sensor nodes, they are connected to each other, and we have done this, we have used this algorithm for even simple cluster, normal. This is a normal one. Here we have made a backbone of connected dominating sensor network. So we have proposed a distance-based stable connected dominating set methodology using a meta-heuristic algorithm, Gray Wolf optimization method. Okay, so we have used GWO for making the efficiency of this network better. So for achieving a stable, balanced and energy efficient CDS, we have proposed this GWO, and we have also proposed this clustering algorithm, that is for identifying a better cluster head also. And we have seen that the proposed method is performed much better in case of the sensor nodes. So how will you, now the question is how we have defined the fitness function and how we have defined the, or how we have used the Gray Wolf optimization method. So basically the, what you call this, one is effective transmission distance, okay. Another one is energy. These are the main two characteristics which is to be optimized. If this is optimized, we can optimize the energy which is being used by the network for communication information to the base station. Okay, so we have two things. One is energy and another one is transmission distance. So what we have done is we have defined a we have defined a dominator lifetime index, that is DLI, which is nothing but normalized way of energy of a sensor network. So suppose the sensor network has, sensor node has some energy, and it will use a particular amount of energy, it will dissipate a particular amount of energy for transferring a data from one location to another. So we have normalized it. So how many times, as the number of round increases, your DLI will come down. So DLI is a measure of approximate lifetime of each dominator node. So we have made an algorithmic framework that minimizes the interquartile range or variation. Interquartile range means nothing but actually the, what you call the variation, the variance of energy among the nodes in the network, that is interquartile range. In like this side, DLI is for a single node and the interquartile range is for the whole network. And then we define the effective transmission distance. So effective transmission distance means maybe it can be transmission from the sensor node to sink or sensor node to cluster head, whichever is distorted. So we are talking about that sensor node, effective transmission. So using that, we have made the fitness function, and maximizing the fitness function, like we have made a vector. Each vector, like if suppose in this case, so many sensors are sensor nodes and only some of them are your dominator, or we can say the cluster head. So if a sensor node is defined as a cluster head, we'll write 1 there. And if it is defined as a normal node, it will be 0. We can have any combination of this. For each combination, we have calculated the fitness function. the fitness function which gives us the maximum value will be taken, and that will be used for the for allocating. Some of them are sensor nodes and some of them are disconnected dominating set. So that way we have then we got a better optimized way of defining the cluster head, and it is a balanced way also, because, and this will keep on, because each time your DLI, as your number of rounds increases, DLI will reduce. So each time this will be varying. So accordingly we will be varying the cluster heads also. So same similar way we have done for cluster heads also, and both we have tested with existing algorithms, and we have seen that energy dissipated by dominators, number of nodes, energy dissipated by entire network or the number of nodes. So by varying the number of nodes, we have calculated it, and we have seen that our algorithm, our proposed algorithm, blue, it is much better compared to other algorithms. We have calculated the instability period also, because see, for some time it will work when you increase the number of nodes, or when you increase the after a long time, definitely this instability period, like it is also going to be instability period means what we can say that till when we have the network. Otherwise, maybe after some time you may not be getting any information. So that is also better in compared to other applications. And we have compared performance with this is actually first donut. This is stability. This last node dies. So this way we have compared with all this leech and this protocol, and with the proposed algorithm is performed much better compared to.
Ma'am, one question has been asked into the chat box that which simulation software is being used?
See, most of the time we used MATLAB only, and we have used this NetSim software for calculating the like peak energy of the sensor nodes, and we have seen that like after applying GW it is less. Otherwise, we have used MATLAB only. You can formulate the sensor node using MATLAB, and then you can define the parameters, and that is being used. Is that clear?
Yes, sir.
So then we have gone through another method, that is adaptive mobile sync algorithm for an energy efficient WSN. So in this case, basically, like this we looked in a different way, and here one hypothesis is there, that is, we assume that the sync node has infinite energy. So that means the sync node, we should be able to charge the sync node or something like that. That assumption is there. Otherwise, this will not work properly. So here what we thought that, like, if we move the sync near to the sensor nodes, then definitely it will be having a better efficiency, or the effective lifetime of the sensor network will be increasing. Okay. So a widely adopted solution to energy hole problem is to divide the deployment region into multiple subregions and use mobile sync to aggregate data from each subregion. However, inside a subregion, cluster heads close to the mobile sync dissipate their energy quickly and die despite of the sync mobility. So here basically, like suppose if you have a, like here, if you keep the mobile sync at a particular location only, always maybe sync will be coming here only, maybe coming here only, or maybe coming here only. Definitely some of the sensor node which is near to the mobile sync will die out faster. So for avoiding that, what we have done is we are mapping the problem of distributing data transmission load optimally to multiple cluster heads and locating mobile sync near the multiple cluster heads using a meta-heuristic algorithm, that is again BBO. We used BBO here. And actually we'll divide it and then we will plan an optimal path for this mobile sync for everywhere. This is what we have tried. The concept of sync node with mobility is considered. If sync node is stationary, the cluster head near the sync node will drain energy. So the optimal location of sync node is identified using BBO, which in turn minimizes the energy consumed by the sensor nodes. So BBO is also used for energy hole-free deployment in sensor nodes. Okay, so again, we have done the same thing, like it's a biogeography based optimization method. So we made this vector and we have cluster head near the mobile sync is also being, this vector is being made. And each time we have calculated the value, that is basically the number of hops and involved, that is the cluster heads near mobile sync, number of cluster heads near the mobile sync. So this way, and we minimize this fitness function always. We use this and then we minimize the fitness function always, and that combination of this vector will be considered as our final output, and we have used that for identifying the optimum location of mobile sync near the sensor networks. So it is something like this. We have divided it into, like, of course, this is possible. Like if you want to keep in a bigger area, we can keep mobile sync only one location. And if you are keeping it only in one location, it is not going to work at all. Okay. So instead, if you make you divide it into multiple locations, like we have divided into 4 part or 6 part or 8 part, so that then you can have a possible path for the mobile sync. And using this biogeography based optimization algorithm, you will be able to identify the location of the mobile sync. And then if you move the mobile sync properly, you will be getting a better efficiency of the sensor network, or the lifetime of the sensor network is going to be increased. So this is also we have done compared with other algorithms, that is standard deviation, node energy, and then rounds, and network residual energy with number of rounds, and all everywhere seems that the proposed algorithm is much better compared to other algorithms. So these were the software based or the protocol based algorithm which we have looked into, and for enhancing the energy efficiency of a sensor network. Now, actually, I'm going to talk about how we can modify the architecture of a sensor node, and it can be used for improving the efficiency. See, I have told you any of this block can be optimized for getting a better efficient one. And what we have done is we tried to improve the processing storage. Improve the processing amount. That is, actually we have designed an energy efficient ALU using Vedic multipliers. This you might have already heard about Vedic multipliers for enhancing the capacity of ALU. So a conventional ALU is less capable of intelligently predicting outcomes based on previous input. Its neural counterpart, on the other hand, aims at improving its prediction capabilities by employing an activation function and making it an intelligent ALU. But ALU designed with neurons suffers from bulky and slow architecture. That is the problem. Like, see, suppose we use a neural network. We can use a neural network for using ALU, but when we use a neural network, then the your sensor node will become heavy, bulky, and it may consume more power, and then you will not be able to use it. So we have used this Vedic logic for improving the efficiency of arithmetic and logic unit of a sensor node. So we know that we all know about this. Vedic logic helps in performing faster calculations by utilizing simple techniques to solve complex problems. To make ALU suitable for sensor nodes, ALU is using, we defined ALU for using Vedic neurons. Okay. And use of neurons in the design gives prediction capability by employing activation function and help to design an intelligent ALU. So to improve the processing speed and efficiency, conventional multipliers in neurons are replaced with Vedic multipliers using Urdhva Triyambaka Sutra. Using these Vedic neurons, arithmetic and logic functions have been implemented. The logic gates are designed according to individual truth table conditions. So we have like basic artificial neuron model is being used for implementing this Vedic neuron. So we have like Vedic multipliers and then adder and then activation function. This way we have a Vedic ALU we have defined, and using that Vedic ALU, like see for example, exclusive OR gate. We know that for these two conditions, like if x1 is 0 and x2 is 1, the output will be 1, and for the other two cases, the output will be 0. So accordingly, we have defined a function that is eta, and then using that we made the Vedic neuron. And we have done this FPGA simulation for this, and we have seen that it is working quite well, better. And see the delay comparison also with conventional, we have compared with the Vedic structure and conventional structure, and Vedic one is much better in case of this. And we have seen that this Vedic logic is better. So the ALU which we use in the sensor node can be the processing element, can be replaced with this Vedic ALU. Another one is we have used the design of improved power amplifiers for making energy efficient transceiver blocks. Now the basic energy consumption is due to the consumption of energy in transmitting data and receiving data. So if we can optimize that, if we can optimize a transceiver for this, definitely your energy efficiency will be really, really high. So in sensor nodes, power is consumed mainly in transceivers, and in transceivers, the most significant power consumption is contributed by power amplifiers. For addressing the challenges, our work focuses on design of switch mode power amplifiers in Class C configuration to achieve improved bandwidth and efficiency of a lower power supply. So to make Class C amplifier suitable for sensor nodes, two different configurations using basic Class C amplifier are proposed in this work. The first configuration is Class C amplifier with double cascoding, and the second design is Class C amplifier designed using common drain followed by common source. Power amplifier using cascode configurations work at lower voltage and the gate voltage and VDS, which leads to reduction in power consumption. Higher output resistance and higher gain can be obtained by adding another level of cascoding. Here, another transistor in common gate is added, and it results in higher output resistance increased by a factor equal to voltage gain. Common gate configuration acts as current buffer. It takes input signal current at low input resistance and provides nearly equal current at very high output resistance. Presence of common gate configuration has resulted in increased load current, thus increased efficiency and bandwidth. So common drain, common source configuration. So the common drain, common source cascading gives wider bandwidth compared with common source configuration. Transistor in common source configuration will exhibit a Miller effect at that results large input capacitance. Buffering action of common drain configuration causes a low resistance across input capacitance of common source configuration. Impedance match provided by the common drain configuration, CDCS cascading results less loss across the load. It leads to high load current and increases the efficiency and bandwidth. So we have like class C amplifier with double cascading. We have used this network, this one, and we have simulated and we have seen that is giving a better results. So like the performance analysis is something like this, like simple class C amplifier. Earlier transceivers were having this, and when we used these kind of things, we got a better efficiency in this transceiver. So now I would like to conclude my work that for any sensor network, energy efficiency is really important, and energy efficiency can be achieved by optimizing data transmission using optimization algorithms. Also, energy efficiency can be achieved by improving the processing element, or even like now every sensor network is to be secured also, and in the security also, if you can provide optimization, that also will have optimal energy conserve, or we can optimize the result. So with this I am concluding. If you have any questions, you can ask.
Madam, I have a question. Am I audible?
Ma'am, you are on mute. Hello.
Hello. If any questions are there, you can ask.
Yes, ma'am. Prashant Kulkarni sir was asking one question.
Okay.
Hello, may I audible, madam?
Yes, you are audible.
Actually, you have implemented ALU by using the Vedic algorithms or a Vedic technique. Actually, we are using the Boolean logic for implementation. So, at implementation level, how we are categorized that this is a Boolean level and this is a Vedic level? Because logic is same, and for comparison, we have some common logic.
Like there actually, see, that was you use that is in the logical level, no? The logical level. See, logic we have achieved, that is for neurons. Logic is for neurons. But multiplication or addition will be done by Vedic mathematics. So we have combined.
Okay, means totally we are not differentiated, only for comparison you have taken that.
Yes.
Okay. Thank you, madam.
Any other question?
Any other questions, please?
If no questions, then we can conclude today's.
Kanksha, you there?
Yes, ma'am.
Okay.
Thank you. I would like to thank you, Indu ma'am, for enlightening all of us with her expertise. We learned various important aspects like concept of sensor networks, how we can provide mobility to sensor node, applications of sensor network, and how we can design the energy efficient sensor network, use of optimization techniques for improving the energy efficiency, and very important Vedic neurons. All are very interesting and very important topics. So thank you so much, ma'am, for this informative lecture. Thank you, ma'am.
Thank you all for patient hearing, and thank you for supporting us for all these 3 days, and we expect the same support from all audience next days also. Okay. Thank you all. Bye.
Okay, participants, the feedback link is shared, so it's mandatory requirement. So please fill up the feedback for this day.
Good evening, ma'am.
Hanji. Hello.
Hello.
Hello. Yes.
Am I audible to you?
Yes, yes, please.
Okay. Did you share any feedback link yesterday, ma'am?
Yes, we shared.
Can you please resend it again? Because before that, my network got closed, so I was not able to give that yesterday.
Actually, the thing is that we are sharing it during the end of the session, like at this time when we are ending the session. So at that time we are sharing.
Okay,
So
ma'am.
okay, so please okay, try to means come at that time and
For
fill
day
up.
one also, did you give any feedback link, ma'am?
Yes, yes, we have shared it for today's session. You can just fill it up.
No, not for today, ma'am. For day one and day two.
Uh, okay, what is your ID?
Mail ID, ma'am.
No,
Okay.
ID.
Participant ID is 7.
Okay, just send me an SMS. I'll check it.
Okay, ma'am.
Okay.
Hello.
Hanji.
Ma'am, I also could not send the feedback for the first day. Day
एक्चुअली
one.
क्या है ना फीडबैक लिंक हम एक ही बार शेयर करते हैं वो होता है एंड पे तो आप इसीलिए वी आर सेइंग दैट टुवर्ड्स द एंड ऑफ द सेशन वी आर शेयरिंग द फीडबैक सो अभी आप आईडी लिख दीजिए लेकिन नाउ ऑनवर्ड्स प्लीज आप उसी पे मतलब इसी टाइम पे खुद आप एक बार लिंक से सबमिट कर देंगे मुझे आई मैसेज कर दीजिए आप
फर्स्ट डे मुझे पता नहीं था कि फीडबैक भी सेंड करना है. दैट्स व्हाई आई डिडंट पे द हीट. बट अभी तो रेगुलर सब कुछ अटेंड कर
राइट
रहा हूँ.
राइट ठीक है हाँ जी इट्स ए मैंडेटरी रिक्वायरमेंट फॉर अटल एफडीपी की आपकी फीडबैक भी होनी चाहिए और ये अटेंडेंस प्लस एंड में हम टेस्ट भी लेंगे एक
नहीं मैडम, यदि यदि फीडबैक फर्स्ट डे का नहीं शेयर किया तो क्या
नहीं कोई
होगा?
कोई बात नहीं आप मुझे एसएमएस कीजिए देन आई विल सी ठीक है
एसएमएस कहाँ पे?
Madam, mine
Can
is
you
also
please
the
share your
same issue,
mobile
madam.
number?
Madam, I also didn't give the feedback for 2 days, earlier 2 days.
कोई बात नहीं आप जितना है ना अब उतना तो कीजिए ठीक है
Yes, ma'am. We have given attendance regularly,
हाँ
but the feedback link we missed it, ma'am. 2
हाँ
days I
लेकिन
filled it completely.
हाँ
Yes,
अगर
ma'am.
हमें कुछ रिक्वायरमेंट होगी देन वी विल आस्क यू अदरवाइज आप इसको जितना है उतना तो फिल कीजिए पहले
Please, ma'am. Ours is 66 ID number, ma'am. Thank you.
ओके हाँ जी
Ma'am, can you please share your mobile number for sending the SMS?
ओके ओके डॉक्टर मंजीता आर यू देयर
Yes, ma'am.
ओके, आप अभी कर दीजिए कल का, लेकिन नाउ ऑनवर्ड्स हम फिर दोबारा नहीं करेंगे, ठीक है? आप
ठीक है,
इसी पे
ठीक है।
भेज दीजिए लिंक।
ओके ओके मैम।
ओके, सो प्लीज
ओके।
पार्टिसिपेंट्स आप अब कर सकते हैं, लेकिन नाउ ऑनवर्ड्स फिर मतलब हम भेजेंगे नहीं इसको, ठीक है? हाँ जी, एक बार कर दीजिए शेयर।
Just give me a minute, I will share.
ओके, थैंक यू मंजीत, प्लीज शेयर।
Ma'am, the session is over. We can leave now.
Please, yes, please.
Okay.
Okay, is there any other query? So,
Ma'am, are you sharing your mobile number?
actually, we have shared these feedback form also. So you can directly
Okay.
fill up.
Okay, ma'am. Thank you so much.
Okay, Hanji.
Ah.